It is the morning of June 3, 2026. This image captures the branding of the St. Petersburg International Economic Forum, an annual event where Vladimir Putin gathers thousands of delegates to project a message of total Russian economic and military invulnerability. But exactly 17 kilometers to the west, reality was telling a different story. This is the Kronstadt naval base, a heavily fortified Russian harbor. Docked along these concrete piers is a Project 20380 missile corvette, known as the Boiky. 2,200 tons of steel, loaded with anti-ship missiles, and valued at $400 million. At that exact moment, a formation of 6 Ukrainian F-P-1 drones was crossing the black water of the Gulf of Finland, heading straight for the port. These machines cost $55,000 each and travel at a sluggish 230 kilometers per hour. Decades of military doctrine dictate that a multi-billion-dollar defense grid built to intercept supersonic fighters and cruise missiles should instantly swat down slow, cheap drones flying in a straight line. That did not happen. Those 6 drones entirely bypassed Russia's premier defensive shield. They succeeded by systematically exploiting specific physical and mechanical blind spots engineered directly into the legacy hardware meant to stop them. The drone's first evasion tactic was an extreme drop in altitude. To avoid early warning detection, the F-P-1s flew just 3 meters above the surface of the Baltic Sea. This diagram illustrates exactly how that low altitude breaks the detection system. Radar waves travel in straight lines, but the Earth curves away beneath them. This divergence creates a phenomenon called the radar horizon. Because of that curvature, a coastal radar installed at sea level physically cannot see a target flying 3 meters high until the object crosses a strict mathematical threshold. The drone remains entirely hidden in the physical gap below the beam until it is exactly 12 kilometers away. No advanced stealth coding is required when the geometry of the Earth itself shields the target. The physics of a sphere easily defeated state-of-the-art radar. The next layer of defense the drones hit was electronic. Russia had activated the Murmansk-BN over the Gulf of Finland, a towering electronic warfare system capable of jamming communications for thousands of kilometers. As this map shows, the Murmansk-BN utilizes a tactic known as spoofing. It doesn't merely block a GPS signal, it actively forges it. The system beams perfectly plausible yet entirely fake coordinates directly into the drone's receiver, tricking the machine into believing it is somewhere else. The F-P-1 has a secondary brain designed for this exact problem, a camera that corrects its location by matching the terrain below with preloaded maps. But flying 3 meters above the water, in the middle of the night, the camera saw nothing but black. There were 0 visual reference points to match. Fed forged coordinates and unable to visually correct itself, the first drone veered off course and dropped straight into the sea. The remaining 5 managed to cross through the interference zone intact. A hardware sensor is entirely useless if the physical environment offers nothing for it to sense. At 9 kilometers out, the drones encountered a Sobol-class patrol boat. This vessel, seen here, is equipped with a devastating piece of hardware, the AK-630 automatic cannon, capable of firing 5,000 rounds per minute. But the cannon has a severe mechanical limitation, illustrated in this side profile graphic. Its elevation guides have a strict minimum depression angle. A physical joint restricts the weapon so it can only aim down to a hard 5-degree angle. With the F-P-1s flying at an altitude of just 3 meters, they slid perfectly into the wedge of safe space beneath that 5-degree limit. The patrol boat unleashed 340 rounds in 4 seconds. Every single bullet passed harmlessly overhead. Overwhelming kinetic firepower provides 0 defense if a simple mechanical joint physically prevents the peril from pointing at the threat. The Kronstadt base commander activated his final line of defense, the Pantsir S-1. This system is Russia's premier short-range air defense, and within moments it fired 4 surface-to-air missiles directly at the incoming drones. The Pantsir is fast and accurate, but it contains a hard-coded internal flaw designed in the 1990s. To prevent a missile from accidentally detonating the moment it leaves the launch tube, the software enforces a mandatory 1.2-second safety delay before the warhead is allowed to arm itself. Traveling at 64 meters per second, the F-P-1 drones covered 77 meters during that 1.2-second window. That speed pushed them entirely inside the missile's 1.5-kilometer minimum arming range. The missiles found their targets. All 4 passed within meters. None of them detonated because the drones breached the defense before the warheads could explode. A multi-million-dollar defense grid fired its best weapons, and those weapons protected the enemy, defeated by their own rigid safety protocols. Once past the missiles, the drone formation split. 2 F-P-1s broke off and kamikazed into the Podlet K-1 radar, the mobile unit shown here. In 4 seconds, the port's 200-kilometer detection capability ceased to exist. The remaining drones converged on the dry dock. Their target was the massive Project 2038 Boiky, hull number 532, seen here. The Ukrainian operator manually aimed the lead drone directly at the ship's integrated mast, the central hub that houses all of its radar, communications, and electronic warfare systems. The impact obliterated the mast, instantly blinding the ship. A second drone targeted the starboard side, detonating a molten copper-shaped charge that tore straight through the 15mm steel plating of the hull. Strip away a warship's sensors and communication arrays, and it is no longer a deadly weapon. It is just a blind, floating steel target. Looking at this view of the St. Petersburg cityscape, it's easy to grasp the scale of the failure. As Vladimir Putin took the podium to assure world leaders of Russia's strength, the black smoke rising from the crippled warship was visible from the convention center windows, just 17 kilometers away. This visual balance sheet lays out the brutal economics of the strike. Ukraine spent exactly $330,000 on 6 slow-moving drones to functionally destroy a $400 million high-tech corvette. That is an exchange ratio of 1 to over 800. Because of international sanctions, Russia cannot easily source the electronic components needed to rebuild the Boiky's mast. The ship will sit completely out of commission for at least 18 months. The math of naval warfare has changed. Identifying and exploiting the physical blind spots of legacy defense systems ensures that cheap software and agility definitively outmatch expensive steel.